Hi guys, welcome back to Astronaut. Today we're using a betta fish to explain how astronomers determine the life cycle of a star.
I feel like an astronaut in what you know about rolling down in the deep.
Imagine you are a betta fish trying to understand the human life cycle. Your lifespan is so short compared to a human's lifespan that you can't actually track a human's life from birth to death. So instead, you have to watch multiple humans within your lifetime and try to piece together how they live. This is essentially how we look at stars. We can't track a single star from birth to death, so instead we look at snapshots of the lives of multiple stars and piece together the stellar life cycle from this information. If the betta fish is in an average household, it will observe a couple of adults, the friends they invite over, and perhaps some kids or older family members. From this information, the fish will assume a large portion of the human population is made up of adults. Now, let's make the stellar comparison. If we take a portrait of a star population, we will see a lot of stars along what we call the main sequence. This is the adult stage of a star, and stars spend the majority of their lives along the main sequence. Younger stars tend to be bluer, bigger, brighter, and hotter, while older stars are redder and cooler. Every stellar family will include the characteristics we have described so far, so we can take this snapshot as a standard example of a stellar population. Now, remember the betta fish has only observed one family so far, and not all families look the same. The traits we observe in this stellar family portrait depends on which cluster we are looking at. In addition to the stars along the main sequence, some populations include white dwarfs or red giants. As stars begin to die, they veer off their life on the main sequence and enter new stages of life. We will talk about these stages in a later video, but visually we can see a trail of stars entering the late stages of their lives in our portrait. We call this stellar portrait an HR diagram, after Hertzsprung-Russell. We'll break away from our betta fish analogy to discuss more characteristics of the HR diagram in the next video. Until then, ponder, wander, and go right in the stars.
In slow motion, yeah. I feel like an astronaut in the ocean. Like what you know about rolling down